Hello everyone, in this video I'm going to show you how to find solutions to exact differential equations. First, we have to determine if the equation is exact, and secondly, we have to find solutions to the exact differential equations. Given a differential equation of this form, p of xy dx plus q of xy dy equal to 0, we can easily match this equation. I'm going to call this equation 1. We can easily match equation 1 with this equation. The psi is del psi del x dx plus del psi del y dy equal to 0. If we match these two equations, equation 1 and equation 2, we would find out that from these two equations, p of xy is equal to del psi del x, and q of xy is equal to del psi del y. To prove that equation 1 is exact, we have to show that del p del y is equal to del q del x. Equation 3. Therefore, given equation 1 a differential equation, we can prove that equation 1 is exact if we can write equation 3. We are going to take an example to show how this works. I have an example here where we are given y prime plus 1 plus y over x equal to 0. When you are given a problem, an ODE, to find if it is exact, check if it is exact and solve it. So first, we have to put it in the form of equation 1 so that it will look like a proper differential equation. Therefore, this can be written as dy dx plus 1 plus y over x equal to 0. I can multiply everywhere by x so that I will have x dy dx plus x plus y equal to 0. I can multiply everywhere also by dx so that I can have x dy plus x plus y dx equal to 0. I'm calling this equation star. If you look at equation star and equation 1, you find out that p of x comma y is equal to x plus y, and q of x comma y is equal to x. Yeah, because this is q of x and this is p of x. Therefore, this equation is in the form of equation 1. Then we can solve it. We can check if it is exact. To check if it is exact, we have to prove, step 2, to check for exactness. To check for exactness, we have to prove that the p dy is equal to the q dx. P is x plus y. Therefore, the p dy is 1. Q is x. Therefore, the q dx is 1. So we have proven that the p dy is equal to the q dx, which is equal to 1. Therefore, the equation is exact. Now we have to solve it. We have to find the solution to the exact differential equation. I need to remind you that the solution to exact differential equations is usually a constant, and it is given by psi is integral of x naught to x of p of xy dx plus integral from y naught to y of q of xy dy is a constant. So this is the solution, this is the form of the solution for an exact differential equation. Therefore, we have to plug in our values into this form of the solution to obtain the solution to the equation we just solved. Now, our solution is psi is integral from x0 to x. Our p of xy is what? Our p of xy is x plus y dx plus integral from y0 to y. Our q of xy is x dy is equal to a constant, which we don't know. So is equal to a constant. Good. Now we have to integrate. So when you integrate this with respect to x, integrate the first one with respect to s, we have that psi is equal to s squared over 2 plus xy from x0 to x plus, we integrate the second one, we have xy y0 y. We integrated this with respect to x and integrated this with respect to y. Therefore, we'd have that our psi is s squared over 2 plus xy minus x0 squared over 2 plus x0 y plus xy minus x y0 is equal to a constant. Then all we have to do, we'll find out that if we look at this expanded expression, there is a repetition. This is repeated. This is repeated. So we can just ignore the repetitions and call them constant terms and select a few of the expressions which come first and let other ones to become constants. So all we have to do is psi is s squared over 2 plus xy. I can let other terms become constant terms. Is equal to a constant. I'm going to call that constant this. Therefore, the solution is psi is equal to x squared over 2 plus xy is equal to a constant. This is the solution to the exact differential equation. Let us look at another example. Example 2. Example 2. We are given 2xy minus 9x squared plus 2y plus x squared plus 1 y prime is equal to 0. The first thing you want to do is to expand this. So you open up this. That should be the first step. So you have 2xy minus 9x squared plus 2y plus x squared plus 1 dy dx is equal to 0. So we want to put it in the form of p of xy plus q of xy is equal to 0, which is the normal form of the differential equation. So we can multiply through by dx. So we can have 2xy minus 9x squared dx plus 2y plus s squared plus 1 dy is equal to 0. We'll call this equation 1. Or I have equation 1 already. I can call it star star. So we can see that this equation is of the form p of xy dx plus q of xy dy is equal to 0. Therefore, by comparison, we can have that 2xy minus 9s squared is equal to p of xy, and 2y plus s squared plus 1 is equal to q of xy. So having gotten those, we have to check if it is exact. To check if this equation is exact, we have to prove that the P, the Y, del Y is equal to del Q, del X. We have to prove that. Okay, now to prove that, we have that del P del Y, looking at it here, our del P del Y is 2x. Del P del Y is equal to 2x, because we differentiated this with respect to y. And our del Q del X is equal to 2x, because we differentiated this with respect to x partially. Therefore, we can see that this is equal to this. So we can conclude that it is exact. Now let us seek the solution. Here, remember that we seek a solution of the form psi of xy is equal to integral from x naught to x of our P of xy dx plus integral from y naught to y of our Q of xy dy, and it must be a constant. Therefore, we substitute our values. Our psi of xy would give us integral of x naught to x. Our P of xy is what? This 2xy minus 9x squared plus integral from y naught to y. Our Q of xy is 2y plus s squared plus 1. All of them are equal to constant. Then we can integrate. Integrating this would have 2x squared y all over 2 minus 9s cubed all over 3 from x naught to x plus 2y squared. Remember that this is the x, this is the y. Sorry about that. So 2y squared all over 2 plus s squared y plus y from y naught to y is equal to a constant. Therefore, we are going to get x squared y minus 3s cubed minus x naught squared y minus 3x naught cubed plus y squared plus x squared y plus y minus y naught squared minus s squared y naught minus y naught is equal to a constant. All I just did was to substitute the values of the boundaries into these expressions. Therefore, as we normally do, we'll just ignore the repetitions and take very few terms. Therefore, we remove the duplicates, and we have that our psi of xy is s squared y minus 3x cubed. I'm going to ignore these naughts, x naughts, and choose this, plus y squared plus y is equal to a constant. Is equal to a constant. This is the solution to the ordinary differential equation. Now, if we are given a boundary condition, say we are asked to solve, we are given a boundary condition, say they give us an initial condition, say y of 0 is equal to say 3, for instance. It means that if we are to apply the boundary condition in this solution, we can simply say that whenever x is 0, y is 3. So we can let all x go to 0 and y equal to 3. So we have that y psi of xy is equal to 3 squared plus 3, which is 9 plus 3, which is 12, which is equal to a constant, which is equal to the constant. Therefore, the constant is 12, and our solution becomes x squared, that's psi, is equal to x squared y minus 3x cubed plus y squared plus y is equal to 12.